We have pretty much the entire problem all on one screen right here, but we're going to be good with this problem there. Make sure you're practicing this stuff in the graphing calculator. So part A just says find the area of this region. That's the top curve minus the bottom curve. They gave us what the two equations were. So when you set up your integral, I just did the top curve minus the bottom curve. So g of x minus f of x, and then you could enter those into the calculator, use the Math 9 feature, make sure you can get that 5.137 number. All right, part B says we got base of a solid, we got cross sections perpendicular to the x-axis. And so I drew a little line segment perpendicular to the x-axis, and to find the length of that segment, that's just going to be top y minus the bottom y. So the S is going to be G minus F. And remember, when you do the cross sections for the volume, you integrate the area of the cross section shape, which they tell us we have rectangles with the height of x. So when they give you rectangles, whatever you find for the ace, that is the base of your rectangle. The area of a rectangle is base times height. So you're going to integrate base times height. So your base is the S, that's the G minus F. And then the height, they have to tell us that, and they did. The height is equal to x. So there's the base times the height. That's what you integrate, is the area of that rectangle shape there. So you integrate the base times the height, so S times the x. And then the same thing from 0 to 3. So Math 9 that thing, make sure you can get that number and practice your shortcuts and stuff with that. All right, so letter C, this is going to be our nice disk method here. We're going to be strong with this. Rotated about y equals -2. So y equals -2. I drew my rectangle perpendicular to that axis of revolution there. That little part is horizontal, making that a dx problem. So remember, the capital R is a distance from the axis of revolution up to the farther edge of your bounded area right there. So if I'm going from the x-axis up, that's always y, but I didn't start from the x-axis and go up. I started back here. So to get from here to the x-axis, that was 2 units I had to travel. And then from the x-axis up was y. So that was 2 plus y. And then that farther edge was the g of x equation. And then the little r is the distance from the axis of revolution to your closer edge. So again, when I go from the x-axis up, that's y, but I started here. So that's 2 units. And then the additional y units. So that's 2 plus y. So same thing. Both of those are one of our big scenarios there. So 2 plus y, but the closer edge is your f of x function right there. And again, you could have this as your y1, you could have this as your y2 in your graphing calculator, and you can just do like 2 plus y2, 2 plus y1. When you're doing, actually, we don't need to even evaluate this one. It says write, but do not evaluate an integral expression. So you just had to set it up using your disk method. So you got your pi guy out in front, and then from 0 to 3, make sure you remember your little differential, your dx right there. And then you got your capital R squared minus your little r squared, and then just set up that integral right there. All right, so make sure you have the inside really, really good. You remember the numbers attached and the pi guy out in front with that dx symbol right there. Okay, so if you're using the disk method properly, you could probably get a point for that. And then if you have the correct stuff on the inside, you'll get another point. And if you have all the little details there, the numbers attached, and then the pi in front, and the differential, that'll be a third point on that particular problem. All right, so the last part gives us g prime. Find the value which the line tangent to the graph of f is parallel to the line tangent to the graph of g. So you know when they talk about tangent lines and slopes of the tangent lines, they're talking about the derivative. So I need to set the derivatives equal to each other. All right, so I need to know when is g prime equal to f prime. So I took the derivative. The derivative of that is 1 plus cosine, and remember the times about the derivative of that angle, and then that's a real easy derivative right there. So I need to take the two derivatives, set them equal to each other, and then if you have a crazy equation to solve, move everything on one side, graph this in your graphing calculator over the interval between 0 and 1, and then let the calculator find the 0 for you. Where does it hit the x-axis there? And that's all we need to do. So please practice the graphing calculator stuff on your own. Make sure you're getting quick with that and comfortable with that. And let me know if you have any questions. That's a good problem for us. Ocelot.